Hello everyone, hope you're doing fine. In this video, we're going to see 10 more questions and I have like 2 bonus questions for you, and all these questions are going to be MCQ questions, and with this lecture, we'll come to an end to the stresses and strains, and from the next lecture, we can go to principal stresses. So let's get started. And before we start, I would really appreciate it if you could smash that like button, drop me a comment and share this free program with anyone who might need it. First question, E, G, K, nu represent the elastic modulus, shear modulus, bulk modulus and Poisson's ratio respectively of a linear, elastic, isotropic and homogeneous material. To express the stress-strain relation completely for this material, at least how much should be known. So let me write the relation between them. So these 4 relations are very important. They are as follows. We have been seeing all these 4 equations for the last 5 videos, I think. So these are very important. So if you're going for an interview or any kind of exam, make sure you know these 4 relationships. In addition to it, in this chapter, the important questions are volumetric strain is equal to stress divided by modulus of elasticity into 1 minus 2 nu. And other important things are, say we have seen what is true strain, right? So true strain is equal to ln of L2 by L1. If it had been a true stress, then it is equal to nominal stress into 1 plus E. So that's it. These are all the important formulas that you should keep in mind. So coming to our question, how many should be known? So if you take say this one. So if you know two things, if you know G and mu, you will know E. And if you know E and nu from the previous equation, you can know K also. From this we can understand that if any 2 is known, then it is enough. So the answer is any 2 of the 4 must be known. Next question. Steel has yield strength of 400 Newton per mm square. And modulus of elasticity they have given. Assuming the material to obey Hooke's law up to yielding, what is the proof resilience? So what is proof resilience? What is resilience first of all? In a stress strain curve, it has something like this. Until the elastic limit, the strain energy stored in the material is called as proof resilience. Resilience, and the maximum strain energy that can be stored is called as proof resilience. So this is associated with strain energy. We know what is strain energy. Strain energy is equal to half into stress into strain into volume. So I can change the strain in terms of stress and modulus of elasticity. Therefore, it becomes sigma square by 2E into V. So this is for strain energy. When it comes to proof resilience, this volume it becomes 1. So proof resilience is equal to sigma square divided by 2E. So on substituting it, first digit is 4. So the only option with 4 here is B. So I am choosing B. Next question. Given that for an element in a body of homogeneous isotropic material subjected to plane stress, Ex, Ey and Ez are the nominal strains, then the unit volume change is what? So what is unit volume change? So volume change, we know it is delta V, and they are saying it is unit volume, therefore we need the volumetric strain. So volumetric strain is equal to simply Ex plus Ey plus Ez. Next question, the stress below which the material has a high probability of not failing under reversal stress is known as what? So here I want you to remember the RCC lecture where we learnt about fatigue. So what is fatigue? If this is my road and these are all my vehicles, they'll be moving in the road continuously. Let me take this strip of road. So this road, it will be loaded and unloaded for n number of times. This loading and unloading, it keeps on happening. So this is only we call as reversal of stress. If you look at the graph between strength and number of load, curve will be something like this. This means that for smaller number of loads, the strength will be high. For a bigger number of loads, our strength will be less. And you can see that after a period of time, it becomes constant. So this part has become constant. So this part where it starts to become constant is called as my endurance limit. And this happens at the 2 million cycles, 2 into 10 power 6 cycles. At this point, the endurance limit would have been reached. So the answer for this is the endurance limit. So we know what is elastic limit and proportionality limit. I want you to comment down the answers of what is an elastic limit and what is a proportionality limit. Next question. Consider the following statements. principle of superposition is applied to linear elastic bodies, yes, and bodies subjected to small deformation, yes. So the answer is both 1 and 2. Next question, a bar is subjected to an axial tensile stress if the volumetric strain of the bar is 0.44 times the axial strain. What is the Poisson's ratio of the material? So it is subjected to axial tensile stress, which means only in one direction the stress is there. Say it happens only in sigma x direction. In sigma y and sigma z direction it is equal to 0. So they have also given that volumetric strain is equal to 0.44 times the axial strain. Let me take Ex here. Because there is only one direction, I am assuming it to be in x direction. So we have seen in the first slide what is EV. EV, that is volumetric strain, is equal to sigma by modulus of elasticity into 1 minus 2 nu, which is equal to 0.44 into axial strain can be written as sigma by E, sigma x, since only x is there. So it becomes like this. So sigma by E can be cancelled. So this becomes 1 minus 2 nu is equal to 0.44. So nu is a Poisson's ratio. The answer is 0.28. Next question. The spherical ball of volume 1000 centimeter cube subjected to a hydrostatic pressure of 90 Newton per mm square, and the bulk modulus is equal to 190 kilonewton per millimeter square. What is the change in volume of the ball? So what is bulk modulus? It is stress divided by volumetric strain. So this becomes, stress is 90 kilonewton divided by volumetric strain is change in volume by original volume. So we know what is original volume, it is 1000, and change in volume is what we have to find, and this is equated to 190 because this is equal to K. So somewhat equal to 473 millimeter cube. Next question. In a stress strain curve, the area up to the elastic limit indicates the mechanical property of what? So this is my stress strain curve again. So we already know if it is up to the elastic limit, that is the area up to the elastic limit, it signifies what? It signifies resilience. If it had been till the fracture limit, then this would have signified toughness. We have seen this already in the previous videos. Next question, stress strain curve for mild steel, load at which considerable extension occurs with decrease in resistance is known as what? It is known as upper yield point. So if you look at the curve, it will be something like this, right? So at a point the stress reduces, that is what they say, decrease in the resistance. So this happens only at the upper yield point. So the answer is upper yield point. Next question, a composite bar is made of steel and aluminum strips with A equal to 3S, where A and AS are areas of cross section of aluminum and steel bar respectively, and ES by EA is equal to 3. During an external load, if the stress developed in the aluminum is so much, then what is the stress developed in the steel bar? So they have told that it is a composite bar. So if it is a composite bar, then the change in length in first bar will be equal to change in length in second bar. So here the first bar, let me take it as aluminum, and the second bar, let me take it as steel. So this becomes PL by AE of aluminum is equal to PL by AE of steel. So length, it is of the same length, so I can cancel that, and let P be so, and A is equal to AA is equal to 3AS. So I can write this as 3AS into this can be written as ES is equal to 3EA. So I am going to keep EA as such, which is equal to PS divided by AS. I am going to keep AS as such into ES can be written as 3EA. 3A is equal to PS. So we know that stress developed in aluminum is 30 MPa. Stress developed in aluminum is equal to force in aluminum divided by area of aluminum, which is equal to 30 MPa. We need to find stress developed in steel. This is equal to PS divided by AS. PS can be written as PA. So this becomes PA divided by AS can be written as AA is equal to 3AS. Therefore, AS can be written as AA by 3. So we know what is PA by AA. So PA by AA is 30. So this becomes 30 divided by 1 by 30 and 1 by 3. So when 3 goes here, it becomes 90. So this is your answer. The stress in steel is 90 MPa. So with this, 10 questions are complete. I have like 2 more questions for you. We can consider them as bonus questions. So the steel track is laid by joining 30-meter long rails end to end. At 30 degrees centigrade, there is no stress. At 50 degrees centigrade, what will be the stress if alpha is so and so and E is so and so. So in the previous videos, they have directly given the change in temperature. Here you have to calculate. So that is the difference. So the change in temperature is 50 minus 30, it is 20 degrees centigrade. And then we know what is the stress that will be developed. Stress developed is alpha into E into change in temperature. So 44 into something. So I have only one answer similar to it. So I'm ticking option B. Next question. 3 strips of same area of cross section share a load of so and so. If the Young's modulus are in the ratio this, then what is the load shared by the strip with the Young's modulus E1? So let me take this equation here. So this is E1 is so we know that E is equal to stress by strain and stress is equal to load by area. So I can say that E is directly proportional to P. So E is directly proportional to P, and also they have given that it is of the same cross sectional area. In place of E I can write P. So this becomes P1 is equal to, they have asked for the Young's modulus with the first strip. So we are going to convert all these things in terms of P1. So this becomes P1 is equal to 2P2, which means P2 is equal to P1 by 2, right? So this equation becomes something like this. They have also told that the load shared is 5.5, which means this plus this plus this is equal to 5.5. So this becomes P1 plus P1 by 2 plus P1 by 3 is equal to 5.5. So this becomes P1 plus 3P1 plus 2P1 by 6 is equal to 5.5. This is like 11P1 by 6 is equal to 5.5, and this is 0.5 times, therefore P1 is equal to 30. This is your answer. No, it is equal to 3 kilonewton because it is 0.5. So your answer is 3 kilonewton. Next question, true stress is related to conventional stress as what? So we saw in the first slide itself, true stress is equal to conventional stress into 1 plus E, the strain. So only this satisfies that. Therefore the answer is option D. If it had been true strain, then it is equal to ln of L2 by L1. L1 is the initial length. With this we come to the end of the video. Thank you so much for watching, guys. From the next video, let us look into principal stresses and stuff like that. I hope this was useful. In case it was useful, please do comment below. Thank you so much for watching. Subscribe to the channel and click on those notification icon. And I'll see you in the next video. Bye bye. Take care.